Oh, all right. It is now 1 o'clock. Laughing time. All right. You wanna talk or you talk?
All right. Oh, wow. I did talk. Yeah. Um, Hello, everyone. This is the IPPM session at IETF 121 in Dublin. You're all very welcome. If you're in the room, please try to join the session through your on-site tool on your phone or your laptop so we can keep track on how many are here. Um,
Uh, I did notice that the on-site tool says that there's no session ongoing, which is a problem. If you join the full client, which is not the one you're supposed to join when you're here, but you can, then it should work. Um, I guess. Uh, you want to read it, Warren? Can you reach out to me, Deco? Yeah, thank you. Um, yeah, while we're waiting for that, if people in the room are having trouble, we will allow you to queue locally, and we will just have to manage that.
that's right. And here we have the note well. Please take a look at it. We're early in the week. Most of you have probably seen it many times before, but please familiarize yourself with the contents of this one. It has to do with things like how we handle IPRs in the ITF, but also things like codes of conduct and so on. There are a number of BCPs that you should be reading if you want to participate here in the ITF. So please do. Yeah, meeting management. We just talked about this. You're supposed to be able to join on the on-site tool. If it doesn't work, yeah, we'll hopefully fix that. Um, uh, you can. We have all the slides uploaded here. We can drive them for you, and you might be able to drive them yourself. We'll see if that works. Um, we will have we have a note taker tool, and we are going to need a note taker to help us take the notes for these in this tool. And if you're not comfortable doing it yourself, it's totally fine to have more people working on the notes in parallel. You can support each other. It's easy if you miss something, etc., etc. But in order to progress, we do need someone or some people to take notes.
Somebody
Somebody.
told me.
So we are blocking here until we have a note taker.
Will Will you be willing to take notes once you're set up? That's fine. That's fine. We will make sure to highlight all of the important things that need to be noted down for posterity. Oh, can you? Great, thank you. So we have Craig, and what was your name? Kaspar? Kaspar? Thank you.
Excellent. And just focus on taking down the important things, like if there are action points, decisions, etc. You don't need to relay the entire conversation. Yeah. Okay, we have a pretty packed agenda this time, as usual. And as usual, we will be have focus on adopted working group documents in the first section of the meeting. So we will start with a short update on IAM data integrity, and then we will have a couple of presentations from Greg on capacity. Oh, sorry, we will have a presentation of capacity protocol, and then we will have two presentations from Greg on hybrid two-step and asymmetrical packets. We have the stamp extension headers, quality of outcome. We have a update on responsiveness, and then finally alt-mark deployment. Then we have the second section of the group of the meeting, which is uh, somewhat longer presentations about work that is related to what's going on in the working group that has seen some level of discussion on the list, so they could be candidates for adoption. So we have three drafts to be discussed here, 10 minutes each. And then finally, we will move into the lightning talks section where we have a lot of presentations today. So please, if you are here to do a lightning talk, try to keep them brief, focus on one slide, capture the key points of your proposal, to get people interested, and then hopefully there can be more discussion on the list or in the corridors or anywhere, and maybe you'll get more agenda time next time. So, but we'll hope that we can, go through all of these in time in this meeting. Okay, so moving on then to the status of this IOAM integrity protection draft. So it was presented here at the last meeting, and then after that we had a working group last call. It was issued in late August. Unfortunately, we didn't get any feedback from or any reviews from the working group. But we did get a very good and comprehensive sector review from Benjamin Kaduk. That was really good. It's a follow-up of earlier reviews that he has been doing, and there has been a really good interaction between him and the authors. So I think a lot of the issues raised there are being addressed sufficiently. But we would, of course, like to progress this document. And in order to do that, we would need review from the experts in the working group as well. So please, this is a kind of a call to everyone here. Please take a look at this and review the document, especially when a new revision is going to be updated here soon. So please take a look at that and provide your feedback, because we would really like to see that before we progress it.
Yeah, I want to echo that. And I think I want to go a bit further, that like we do need eyes on this in order to progress it. And I want to kind of pause here and ideally get hands of, let's say, 4 people who can commit to reading and reviewing the document. You don't need to do it right now. You can just do it as part of the last call that we'll make, but I want to get names down ideally, so that we can make sure to ping you if we don't get the reviews. So who would be able to help on this? Ideally, if you've been familiar with any of the other IOAM work that's gone on in here, or not. Greg, thank you so much. Can we get 3 or so other people who are willing to review this as part of our last call? Thank you. Thank you. Yeah. All right. Yeah, can you just make sure we get your names for the note taker, or if you can just put it in the notes themselves. Thank you. All right.
That's excellent. So then we will move on in our agenda, unless we have anyone who wants to do any agenda bashing. Meet Echo is fixed. Please join the on-site tool if you haven't. Thank you for that. So if no bashing, then we will move on to capacity protocol.
Do you want me to share?
Is it working? Yeah, I see. Hi, I'm Rüdiger, Deutsche Telekom. I'm co-author of that draft, and the last status we have reached was in the early sector review to present our approach to authentication and encryption in the CFRG, which we did last time. And the reaction was that the ideas we presented were not particularly good, and I've been asking them to get some advice what to do, and that is what they did, which is quite great. So that was quite helpful. And my co-author, Len Javatone, he's the person doing the work. I'm the person doing the presentation. He edited that, and that is the outcome, which is now in the version 10 of the draft. Partial encryption was foreseen earlier, and that is still optional. The approach on encryption in combination with authentication is new and now follows the advice given by CFRG. We now first add a randomized initialization vector, IV, and that one is independent from the auth digest. That is one change which we implied as compared to the earlier versions. And also this IV is set newly with each message. That was another complaint. The size still remains 128-bit, which is as before. Then encrypt the parts of the message to be encrypted. That's not the full message, it's only part of the message. We left that. And this is still 128-bit AES CBC, as we've done earlier. And then finally, the entire header is authenticated and the auth digest is added, and that is still HMAC 256 SHA, as we've been foreseeing earlier. Right, and we've sent that to Brian Weiss, who's doing our early SecD review, and he said this looks good. So I think we've passed the early SecD now, and yep, you can switch on because that has been the important stuff. And now there are some more changes which have been introduced by Lan. He's been introducing an optional UDP checksum and justified that because there are some low-end devices and disable UDP checksum. So he integrated an optional UDP checksum to get around that if it is important to have it. And further, there has been some material removed, which was not really helpful. This is largely security-related text, but that text never specified anything and discussed features which were not applied by the draft, like a test protocol for one-way IP capacity. The optional fully encryption mode, that was for information only, and mainly it discussed things and then said, oh, we don't support it in this draft. Brian again gave us feedback and said, oh, that's a good idea to remove this stuff because he felt it to be a bit confusing and quite unnecessary. So that is where we are. And having completed this early SecD review, that's at least what I understand that we did. My point of view is that we are now ready for last call. And I'm open to comments if there are.
I have one question. How have you have an implementation of this as well, right? And
Len has.
Len has. And do you know if he is up to speed with the latest
Yes,
draft
yes.
revision?
I think what he does is he writes that stuff only after he has implemented it.
Okay.
At
That's
least
useful.
that's my perception. You know.
Yeah.
Just as observer, I'm not sure that.
Say your name for the note taker.
Greg Mirsky, Ericsson. So there have been open broadband effort of implementing it, and actually that might be even better than one single implementation existing. But yeah, Broadband Forum has been working as open broadband initiative on implementing it, and that's as Rudiger characterized. They document only what already implemented, which is very good. So it's proven.
Thank you.
That is very useful feedback. Yeah.
I'm not aware of the status of that open broadband thing because I'm not active in broadband forum. I can only say that there is an implementation of the UDP speed test, and that is a control protocol working on UDP speed test. So, but I personally don't know what is has been published in Open Broadband Forum. So if the protocol is published there too, yeah, that would be great, of course. But I will have to check with Lan.
Just in continuation, Greg again. Yes, then actually, I really appreciate that Rudiger committing his time to finish the work that's been started by L. Morton, and L was working, and he managed to publish the document at the 471 series at Broadband Forum. So this is, I think that's something that we should do to get publication to last call.
Thank you very much.
All right, so I just want to, I guess, first, if there are any other questions, please in queue, come up. And then I'd like to get a sense from the room of how many people have, I guess, read a version of this and have followed along. I assume, Greg, yes. Any others? Okay, Bjorn. Okay, so a couple people. I guess again, I think maturity-wise, this document should be ready for last call. I do want to make sure we have sufficient review and participation. So again, just like at least we don't need names on this one. Just like show of hands. Can you just say like, yeah, look at this as it goes through last call. Thank you. Thank you. Anyone else over here? Ideally, when you are also, contributing documents to the group, it's going to be good to make sure we review each other's work too. Okay. All right. Thank you, Rudiger. Then
Thank you.
that should be it. And I guess just for the minutes too, when we, if we just write down that when we do the last call on that, we will formally will ask for the sector last call review, because I think the status of the most recent sector review is still has issues, and so we've resolved it. It'll be nice just to get kind of the formal on the last call that it looks good. So let's just note that down.
All right, and then we're moving on to hybrid two-step.
Yeah. Okay, let's move on. So the work on hybrid two-step protocol, what it is, as we discussed, just a recap. So this is not a measurement protocol. It's a for collection of operational state and performance metrics, could be applicable to in situ OEM direct export or alternate marking method, as these produce information that needs to be collected and correlated. So hybrids two-step, by their nature, it's improves the correlation process as it collects information being collected over sequence of trigger packet, whether it's just one trigger packet or a sequence. Then it could be statistically processed locally and then collected, correlated, and for their network analytics. It could be used in point-to-point, point-to-multipoint modes without unnecessary replication of their collected information, because it creates a separate follow-up packets on each branch if it's a point-to-multipoint tree downstream. And as it can collect information in downstream direction, it can collect information in upstream direction. So it removes the limit of amount of information because, for example, one of the issues that we know about from trace option in situ OEM, as it requires the space in the data packet itself. So their amount of information and number of transit nodes can be a concern and limit the amount of information being collected. So some nodes would further downstream, might not be reporting information. Their hybrid two-step operates by adding new packets to the train of collected information. So thus, there is no physical limit. At the same time, the advantage of hybrid two-step could be seen as it separates the generation of information and collection and transport information. So which improves the accuracy, for example, of delay measurement, because it's challenging for taking timestamp on transit and putting it in the same packet that's supposed to transport it and adjusting the checksum, because it's in the header comparing to FCS code in Ethernet. So by separating these two events of taking timestamp and transporting it, it could be taken when their physical process of transmitting the first byte begins. So thus making the timestamp consistent and avoiding unnecessary variation because of the queuing delay. At the same time, so it allows for separation for their impact and the bandwidth utilization, because it can use a different forwarding treatment, lower class of service, so thus not impacting the bandwidth, not consuming the bandwidth that is dedicated for their client data flows. And furthermore, it allows for dedicated integrity protection of the collected telemetry information. Next slide, please. So what updates? We received IANA early review. We addressed them. There was just recently, after the lock on updates, minor editorial recommendation from IANA, and it's already been in the pipeline, so it's already applied. Also, discussing their IAM HEC header format, we made some changes and proposed some changes for your consideration. Next slide, please. So what you can see here is this is their format that's used for IAM direct export. So it has additional, so the change from their earlier version of this draft is that we allowed for optional flow identification and sequence number. So these are not parts of their HTS protocol because HTS protocol allows for sequence numbers of its own. But these are sequence numbers of the packets that are collecting following the same trigger packet. So these are internal for IAM. So if IAM wants to use it for their own, for example, sequence number, and if they apply it for some sort of the packet loss detection, so they can use it. Furthermore, what's interesting is that now there might be an interesting use case for combining IAM DEX trigger packet with the HTS header. So you can just imagine that you have a sequence of the IAM DEX headers with their HTS header, which effectively gives you an opportunity of doing alternate marking method. So the use of these headers in IAM trace options allows you to instantiate, get the same result as alternate marking. Next slide, please. Okay, so we welcome your comments and appreciate it, questions, suggestions. And the authors think that this work is ready for the last call when we upload the last version that update addresses their IANA comments.
Any questions on this presentation? Then we would probably like to ask the same thing as we've done for previous documents. How many people here are like aware of the progress of this document, have read it, and are that's good. And how many of you are willing to commit to reviewing this document in a last call process? Okay, that's a number of people. That's very good to see. Thank you.
Well, then it's 4 or 5 on both.
Okay, we can go next.
Thanks, Rick.
Let's keep rolling.
Yeah. Nah.
No names.
I only get names.
Okay,
when
I know names, but I will not reveal them.
Yeah.
But thank you, I appreciate it.
This is the escalation step.
Okay, so next to your attention is another extension for the stamp. It's asymmetrical packets, but it's not only for the rate measurement, but at the same time, it's measurement in multicast environment layer 2 and layer 3. Let's take the next slide. So their updates are to address comments from Zheng Li. Thank you. And we received the comments from Rudiger, and we are working on addressing it. And I'll be sending a proposal to update hopefully soon. At the same time, so we clarify the security consideration to replay attack. Next slide, please. So how it complements their base specification of STAMP. We support the performance measurement in a multicast environment with the ability to do selective reflection from layer 2 and layer 3 nodes so that to control the amount of information being returned, not to overwhelm the session sender. And it's easy to combine with additional extensions. For example, it could be with a class of service or return path TLV for the segment routing, for example, scenarios. So it's very suitable for different scenarios and different combinations of stamp extensions. Next slide, please. So to address that security, that we clarify that if stamp is used in unauthenticated mode, so that should use HMAC TLV to do the protection of integrity of extensions. Because as you recall that stamp supports authenticated mode that does HMAC authentication on the whole test packet. But at the same time, it could be optimized in some environments that the base format that includes timestamps and counters, but uses extensions, so the extensions can be protected using HMAC TLV. Okay. So next slide. So with that, it's all the scope of our updates since the last meeting in Vancouver. And we welcome your questions, comments, and suggestions. And as in previous presentation, authors believe that this draft is stable and is ready for a working group last call. Yeah, of course, given that we'll address and get the confirmation on all updates addressing Rudiger comments.
I'm Rüdiger Geib, and I've been making that comment. So I appreciate the work, and I think it's useful in many cases, and also that you try to test the multicast is certainly helpful. Apart from security, what worried me a bit, irritated me a bit was that it's the name and abstract is asymmetrical packets, but it's indeed one thing that the packet is asymmetrical, but if I understood it right, and I'm maybe wrong,
No.
it's also the number of packets which
Yes.
could be asymmetrical.
Okay.
That should be highlighted.
Yes, Rudiger, of course.
Thanks.
So again, I'm probably, okay, I'm definitely half through the comments proposing addresses, might be even further. And I agree with your point that yes, this needs to be clarified, and I agree to changing the name from packets to traffic, so asymmetrical traffic, and clarifying that their response can be variable for the single stamp packet transmitted by a session sender. There could be a variable number of packets and variable length of reflected packets. So that will be reflected, and I will send a proposal for your consideration, and we'll work it through. Yes.
Thank you.
Thank you. So it sounds like you have some some work to do with the reviews and updates, and then
Yes.
based on that, we can see how we can move forward.
Excellent. Thank you.
And next up, we have Rakesh.
Good afternoon, everyone. My name is Rakesh Gandhi from Cisco Systems. I'm presenting the draft on stamp extension for reflecting stamp packet headers. So it used to be extension headers, now it's more headers based on the review comments. On behalf of my co-authors, next slide, please. So agenda is look at the requirements, some of the changes we made to address various review comments received on the mailing list. We'll just flash the work happening in other working group and next steps for this draft. Next slide, please. So requirements is basically to reflect packet headers. It's the motivation is hop by hop and edge to edge measurements in one-way mode or two-way modes. The goal is to leverage the existing implementations on the midpoint nodes and avoid IPv6 and PLS protocol extensions. And so far, that has been the case. And the scope is really the stamp and existing IPv6 and PLS work and RFCs that's out there. Next slide, please. So summary of changes, welcome co-author Zhanxiang. We have updated procedure for the reflecting extension headers. We added procedures for reflecting fixed IP headers based on the review comments and the various editorial changes. Next slide, please. So the first one being updated the procedure for reflecting extension headers. So there was ambiguity when there are multiple extension headers with the same length. So we avoid ambiguity using the pre-filling the first 4 bytes and checking it on the reflector. There is text added for handling the MTU. Make sure we don't add too many stamp TLVs and not exceed the MTU. And the last one being if reflected stamp TLV is not used for some reason, then it's returned back to the sender as malform. Next slide, please. The second set of changes is adding the fixed headers. Motivation is reflecting the IPv4 and IPv6 header back to the sender, but it's also applicable to other fixed header size as well. Next slide, please. This is just a clarification, is adding the extension headers in the reply packet header. Either it's all of them are added or none. So there is no intermediate add this or not add that kind of behavior. Next slide, please. So there is a stamp work going on in other working group, especially the SRPM in Spring that defines measurement modes. We requested working group last call there. So welcome your comments. I also sent the email on the IPPM mailing list as well. And I think we received comment from Rudiger. So thanks, Rudiger. And there is some work happening in MPLS working group as well for pseudowires. Next slide, please. So I think it's ready for working group last call. Maybe we give it some time. Changes were posted 2-3 weeks ago. So let it settle a bit, but I think it's almost ready for last call. But welcome your comments and suggestions. Thank you.
Any comments, questions right here?
My only comment, I have read this document and yeah, it's well written. And my only comment is to add the reference to the document that I'm presenting later on that where I generalize, let's say, the idea to combine active tools and hybrid methods for hop by hop measurement.
Yes.
So
Yeah.
so you don't need to explain, you can just reference that document. If it will progress, it will progress.
Yeah, it has IOM use cases, so maybe this is another use case we can add. And I think this was a question too that we asked in the mailing list. If you thought of a use case, let us know so we can put it as an example in the draft. So we'll definitely do this.
Okay, we can sync up about that.
Yeah, sounds good.
Just to clarify, you're suggesting like just like an informative reference just to help give examples.
It also depends if they can progress together or not. I don't know. So, but in the end, it will be an informative because it's not a standard document.
Yeah, right. Exactly. So like this doesn't need to be normative. So there doesn't need to be, even if your document doesn't ever become RFC, like you can still reference it and be like, hey, here's some good background if you want to read more. Yeah.
Yeah.
Cool.
Okay, thank you.
Next up, we have Björn, quality of outcome.
Are you going to be asking for last call too?
Nope.
Okay.
I'm not.
We're going to break the streak.
Yeah. All right. Hello, everyone. My name is Björn. I'm from Domus, and I'll be presenting about quality of outcome. So next slide, please. This is the agenda. There are some updates to the text. Mainly, we've added explicit loss requirement and calculation. I won't go into the actual changes to the text in detail here, but they are found on GitHub and on the data tracker. And then I want to present some results from a user trial that we've done with Comcast customers. And we have some feedback on the accuracy of quality of outcome and on sort of users' impression of it compared to some other network metrics that they're used to seeing. So next slide, please. First, I want to remind you a little bit what quality of outcome is and what it's designed to be. Our intention is that it should be a one network quality framework that addresses the needs of three audiences, vendors and operators first. And we think that they need like precision, repeatability, and composability to be able to pinpoint problems, to do repeatable tests, that kind of thing. The second audience is applications, which basically like applications, they just want networks not to cause problems, and they want to help end users like fix their problems or achieve a network that works for them. And then finally, the end user, and they when they think about the network at all, um, it's like when the network is causing problems or if it's causing problems. And I think a network quality framework for end users should be able to tell, is the network causing problems? And if yes, how do we fix it? So that is the goal with this work. And the presentation will go through, or what the new work that we've done since last time is basically looking at, are we addressing the needs of end users by running a user test and sending out questionnaires and asking them what they think. Next slide, please. Yeah, so the way that we think we're addressing these needs are basically for the vendors and operators, it's by using the quality attenuation framework from the Broadband Forum, which has all of these features, precision, repeatability, and composability. For applications, we think that measuring network quality in this way makes it possible to expose like expected stability numbers to the applications if they want that and can use it. And then also root cause analysis in the cases where the network does not work well. And similarly for the end users, they can get a score that says, like when you start a video conference call, for instance, you could get a score that says the network right now is likely to support this well or not. And then when it does not, we can again dive into the root cause analysis. Next slide, please. Okay, so this slide has a lot of text. I just wanted to include as much as I could about the method. We had emails sent out to existing Comcast customers where we told them what the sort of terms are for the study. They get a new router, a $200 gift card if they complete the study. And then we sent an initial questionnaire to everyone who signed up. Selected 25 participants from that group, sent them a new router with setup instructions. They used it for a week, 10 days, and had to have like a certain amount of devices connected and that kind of thing. And then following the period of the test period, we sent them a new questionnaire and a link to a tool that showed them their quality of outcome scores for their home network and their devices for the last week or 10 days. And there are some known weaknesses with this approach, like selection bias. That's part of why we're offering the gift card, is to sort of not get only people who are interested in it for the like network metrics, and also people who just like don't know that much about networks. We have, I mean, there are some participants, but relatively low end. We don't expect this to be a fully representative sample of the population. And part of the appeal of the tool that we show them, and I will get to that on the next slide, is that you sort of get per per device quality scores, but we didn't have device fingerprinting, so we couldn't always tell like which device is which device. So we're showing them just the MAC address. So a real product with this would be better, because then you could say like, this is your MacBook, this is your um, TV, right? Next slide, please. All right, so this is the tool. It is showing the quality of outcome score as the graph over time, and they could choose like which application do you care about? Is it video conferencing, gaming, streaming, and what time period do you care about? And then we have like a list of like top recommendations for what to fix and how big the impact of those fixes can be. And next slide, please. Yeah, so now we're getting into the questionnaire results. So next slide, please. So the main takeaway for us is that people seem to really like quality of outcome. So they like the vast majority of respondents say that they feel like the score more accurate reflect their experience more accurately than like the bandwidth that they subscribe to. They like the results better than speed tests. They think it's important that it's an independent standard and not something that the ISP has come up with themselves. And they would be likely to recommend it to friends or colleagues, which is surprising to me, but that's what they say. Next slide, please. Another thing is, how well does quality of outcome match your experience? And this was also a much better result than we were hoping for. Honestly, like 1/3 says it's a perfect match, and no one is saying that it doesn't match at all, which was very encouraging. Next slide, please. We also ask a few questions about trust and satisfaction, and to summarize, like people report that getting network quality scores in this way would improve their trust in their ISP and their satisfaction with what they are delivering. Next slide, please. And this slide, I think, it gives me some hope that ISPs will actually deploy this and start using it, because when we asked customers like, would you be more likely to, for instance, buy a more premium router from your ISP if it sort of, if we quantify the benefit in terms of like, this will make your applications work better, instead of just like saying it's better, like how much better is it? And people seem to like that approach. Next slide, please. Yeah, and this is a quote from one of the trialists. I like this tool because it gives better understanding of what is functioning to which capacity and how to improve it, rather than deal with mystery problems in connection and speed. Next slide, please. All right, and this is the final slide. So this is just showing quality outcome scores broken down by interface. And I think sort of the most obvious thing here is that Wi-Fi is much worse than cable. But what there's some nuance to this. Like this is actually measuring including the access link, which is DOCSIS for Comcast, right? So and DOCSIS is, I mean, not as stable as fiber, but it's still, like, paired with Ethernet, it's still definitely good enough to deliver a good gaming experience most of the time. But Wi-Fi is not, which is interesting. Well, most of the time, that's not fair, actually. Wi-Fi as well delivers a good experience most of the time, but it is much more likely not to deliver a good experience. All right, and that's everything I have for you. So please reach out to me or come talk to me if you want to discuss this in more detail. I would like to spend more time, but I am out of time now. So thank you very much.
Stuart. Thank you. I'm Stuart Cheshire from Apple. Bunch of interesting results here, but particularly this last slide. it'd be great if you can present this or have somebody show this at the IEEE meeting next week, because there's been some fairly contentious discussion in the Wi-Fi community, or I should say the 802.11 community at IEEE, and there's a bunch of people who are playing the layer violation card, which is uh, we're not going to set ECN bits because we don't do layer 3, we only do layer 2. And I find this very frustrating because milliseconds do not respect the OSI 7 layer model.
Well said.
We keep trying.
And what's interesting here is that long distance technologies like cable have really got pretty good, and wired Ethernet is pretty good, and Wi-Fi is becoming the weak link in this chain. And rather than uh, I don't approach the 8 to 11 people with a view that like I'm asking you to do me a favor. I approach it like I'm coming you with a warning that you are falling behind, and you can choose to stay relevant or not, but there's a storm coming, and don't say I didn't warn you. And this, I think, is a great piece of evidence to support that.
Thanks.
All right. I put myself next in queue just as an individual. So I guess a question on the study here is like I see how you're breaking down video conference and gaming as categories. How much are these corresponding to the particular application services like, for video conferencing, WebEx, Zoom, Meet Echo, FaceTime, whatever. And those are all going to have different quality of outcome distributions. Were people just kind of self-indicating what they were using? Do we have a different tuning of quality of outcome per actual service, or is this just like, we came up with one that generally fits video conferencing, and we told like, how did you even know like that was the thing they were using?
So these numbers are sort of hypothetical if you ran a video conference.
Yeah.
And we did exactly what you alluded to there. Like this is a requirement that is intended to fit most video conference applications, and we've
Yeah.
tested it sort of um, manually, and or we first set a requirement based on like just the research that has been done on the latency requirements for these different things, and then we tested that it seems to make sense, and then we used those requirements for this trial. So it's one requirement for video conferencing, and then we're just applying it to all of the data that we have collected.
Okay, so then you would collect the data from the network and say, based on what we see in general from you, we would expect that video conferencing would get this outcome.
Yep.
Which works. I guess, like, I mean, looking forward, if you're talking about like, trials and how this is presented to users, it would be great to also know that like I use this video conferencing product. How is it going to work? Because if there is a difference, or like, right, like, is FaceTime in iOS 18 going to work well versus WebEx from my Linux box or whatever? Like, just being able to know that, because then it's even more compelling evidence that the thing I care about
Yeah.
is going to behave in this way, at least based on the predictions I have.
I absolutely agree. And the sort of ideal scenario for us would be to find an application like this to work with that could sort of help us find the correct thresholds to set, because it's a lot of work to like manually go through all of the different apps, and we just can't spend that time. But yeah, I mean, I agree that would improve the results, and it would also make it more useful for everyone. So yeah.
Rüdiger Geib, Deutsche Telekom. I'm active in ITUT study group 12 too. And yeah, the question mainly is what I see here in quality 0 to 100 is a percentage scale, and it's related to network performance. Is that correct?
Yes.
Right. So it's not a MOS scale, and it's not reflecting any user perceived quality of experience.
We're not measuring the user perceives quality of experience. No,
Right.
we are measuring the latency and the packet loss, and then
the
we're
packet
relating
loss.
it to requirements that we've designed and tested for this type of application.
I think it's quite important to highlight that this is not related to user perceived quality. That's
I have to disagree that it's not related though. That's not what we're measuring directly, but I do think it's correlated.
Oh, it's correlated,
Yeah.
yes. But from the scale, you cannot say we're good, bad, and mediocre starts. It's
No, not exactly.
right.
Yeah.
Thank you.
Hi, Juan Carlos Zúñiga, Cisco Systems. So I had one comment, but now I have three. So the first one from the Wi-Fi point of view, you mentioned that it's correlated to MAC address. Just be aware that there's MAC address randomization happening now. So then you may change that
Yep.
MAC address, and you are actually following the same device, and it may show up as two different ones.
That's
So
correct.
that was
Yeah.
the first technical point. The second one, following up from Stuart's comment about presenting an IEEE 8.11. Indeed, we're meeting next week and we're discussing these topics. So one forum to present very easily there, it's called the Wireless Next Generation Group,
Yeah.
that it's open for non-members to, and I'm willing to help if ever you need a waiver or a remote presentation. I can put you in touch with the chair.
Yeah,
It's very
interested
easy
in
to
that.
do.
Yeah.
It's
Thank you.
actually happening next week in Vancouver time, 8 o'clock local time. So just to say an opportunity, it happens every 2 months, but there is one next week. And the third one, I agree with Rutger that if ever you present there, they are very, very specific. So I think I would interpret his point as, is this subjective or objective? So they really want to be objective and they don't want to see like, oh, good, bad. They want to know exactly what you're measuring, what is it, how you calculate it. That's the type of questions that you will get
Yep.
100%. And I think you have the data, just be aware that that's actually what people are going to be asking and looking for to understand the presentation. But all in all, very good work.
Thank you.
Thanks.
That's great feedback. And I should also mention that this work has been sponsored by the Comcast Innovation Fund as well. And also the report. If you look at the slides, there's a link to the full report if you want to have a look at more of the data and the details.
Abhishek from Meta. So what's interesting here is that the median values do not vary that much, but then the number of outliers that have very low quality in the case of 2.4 and 5 gig is pretty significant. I mean, all your outliers are above 80 in the case of Ethernet. So essentially what that means is that most of the users, most of the time were okay, but there were a lot more instances of very poor user experience, very poor outcome once in a while, which are the people who are more likely to sort of give up on the service that this doesn't work. And so even though those outliers may not be many, but they're significant because those are the users most at the risk of just having a bad impression of the network or the application or just completely give up phase, right?
Indeed, and I think that that's a great way to put it. That it's like delivering quality is not about delivering a good outcome on average. It's about making the bad experiences rare. That's the goal.
Sorry, just one follow-on question to that. To what degree are those outliers on Wi-Fi just because it's it's difficult on Ethernet to be pretty far of range, like I'm plugged in or not, and I can definitely be at a very poor location. So I mean, are we trying to normalize for this? Are these devices that are in known locations that they're being commonly used in, or is this just looking at all data of all packets that went through Wi-Fi, including when I was walking away from my house, and which is a case we care about, but it's certainly different
Yep.
potentially from like in that scenario. I may get frustrated. I may turn off the Wi-Fi on my device because that's a constant challenge. But I'm not necessarily going to blame my ISP or my Wi-Fi router because that's such a common experience. As opposed to if I'm inside my house, then I will complain.
Yeah, we did try to break it down, and there's some more nuance to this in the report. We find that a lot of the problems with Wi-Fi is due to Wi-Fi congestion. So
Okay.
a lot, like too many devices or too many neighbors, or like just too much use of the frequency. And then
Got it.
there is also a very significant portion that is due to like poor, like the range is too, you're too far away, basically.
I'd love to see that like coded in here somehow.
Yeah, yeah. I'll see if I can whip something up. I'll see.
Yeah, Jason Livingood, Comcast. So obviously very familiar with all this data and the study. I think it's important to think about like each of those individual dots there, the circles, is like an individual user session. And today, when a home user is experiencing an internet problem that's due to their Wi-Fi, they just think it's their ISP. It's just the internet's not working. I'm mad at my ISP. So to be able to change that conversation is important and helpful. Also today, generally, the only measurement that the industry provides users is a household-wide. Here's a speed test. Often that is performed to the ISP's gateway, and therefore, by design, ignores the home Wi-Fi network, which is where the source of all of today's problems are from a performance standpoint. So obviously we have a problem, right? Users will run initiated tests all over the place, and they'll think again, like, this isn't my Wi-Fi, this is my ISP that's the problem. And so what do these dots drive? So that's a data point you potentially can provide to the user to say, hey, you're having like a marginal session right now on this specific device using this specific application. You might want to move closer to your access point. Or this has been a pattern. You should install a Wi-Fi mesh network with multiple pods instead of one access point that's in the basement behind the boiler. And so all of those things are good recommendations, as well as like, upgrade to a newer, Wi-Fi 6E or whatever it happens to be access point, are also valuable, recommendations. And that's a sea change in the type of recommendations that you can give users, and you can make it extremely actionable, particularly where you can say, Sally in the network running Teams and Zoom has had excellent quality over the past week, but Joe has, using the same applications, has had very poor quality. We noticed Joe was using Wi-Fi on this old device. Like, here are some things you could do to fix that. So I think it's the ability to finally take all these measurements and make them relatable to consumers and actionable. So it's sort of the underlying data feeds that ability to do those things, where that is lacking today. And users don't know the difference between, as we all know, a megabit and a megabyte and a gigabyte and a millisecond, so it's more relatable.
Yeah.
Thanks.
Yeah, and I appreciate how you're contextualizing those recommendations within particular apps and particular user sessions. And my impression is like these pieces of data are like potentially like all the data points from everything going on in those networks. And so splitting it out, I think, would help really analyze what is working well, what is not working.
Yeah.
Sorry for the question. I just need a clarification based on the latest discussions. Where are you gathering all your measurements? I mean, because you're saying to get your customers to test, you were providing a router and they were getting a gift card. The router, is that the where you're implementing the measurements?
That's right. Yes.
Okay. So just coming back to the latest comments, whether this comes from congestion in the Wi-Fi because there are too many users or too much traffic, whether it's the user moving away from the Wi-Fi and so on, are you actually measuring on that router the signal strengths and all of those? So you have that information.
Yes.
You do have.
Yeah, we can measure. There, I mean, there are some limitations, obviously, but the Wi-Fi chips typically report like how many of the TX, how much of the time in the previous second was used by Wi-Fi transmissions, other like unidentified noise sources, and how much time was available for transmissions but was not used. So sort of we can use that data to infer if it's like, is the frequency very busy or not. And we can also look at the RSSI or SNR for each connected device.
So a number of vendors are offering, quality of experience measurements for applications, but they're using based on SDKs that are implemented natively directly inside the applications. uh, would it be interesting to compare on one application the results you're getting from the end device perspective and see where exactly you're seeing the differences between what the end user is seeing and what the router is seeing? That would, having that type of correlation.
Certainly, yeah. We have done some measurements from end user devices as well and done the comparison, but not from um, not with like application level quality measurements. If you get my point. So
But
we haven't looked at the measurements from or not, at least not at a large scale, with the apps telling us like, is it working well now or not?
but
That would be interesting.
just thinking through, one way to do an interesting measurement would be to use two routers, one of them being the client over Wi-Fi of the other, and having your devices connected over Ethernet to the second router. Because like this, you would have the Wi-Fi link. You would see what the Wi-Fi link provides you exactly difference between your exact same measurements on the two routers. You take the normal router and you take another one as a client over Wi-Fi, and the user device is connected to the second one. So you don't care about having an SDK into the application. You do the same measurement at two different points, one being directly the WAN link and one being through the Wi-Fi link. And it's exactly the same traffic you should be seeing. And you can see the differences in jitters and everything between the two, the same identical traffic.
I'm not sure I follow, but yes, let's discuss
Yeah,
because that sounds interesting.
Yeah, discuss separately or take it to the list. I think that's all good. Yeah, and just for time, I think we'll move on. But this is good conversation and feedback. Did you get input you needed?
Yes, thank you everyone. And as I said, please send me an email or connect on LinkedIn or anything if you want to discuss this more. Happy to talk about it.
Okay. Stuart, did you want me to click through for you? Or?
This is a document I've been working on for quite a while. My co-authors are still in the US, so I'm presenting this on behalf of the group. A couple of weeks ago, we did a fairly major update. So I request people to take a look. You could use the diff tool to see what changed. One major thing was we really tightened up the definition of the JSON configuration object. Previously, it specified it in the form of giving an example, and that was it. You look at the example and you guess what's important and what's not. So clearly that needed to be done better. I hope I've done a better job. Please take a look. The other major change is we added an overview section, and we can move to the next slide that lists some of the details. And this is in as proposed text. This is what I think is important, but this isn't working group document, so the consensus is important. And I realized as this document evolved as a result of input and feedback, I felt it had gone off course and kind of lost its way. But I realized we hadn't written down what are the goals of this document, what are the guidelines. So I made a shot at putting down what I think the guidelines are. So if you disagree, please say so on the list or at the microphone. Some of these may be obvious. They're obvious to me. And if everybody in the room thinks they're obvious, then that's great. Number one is relevance. And this just came up talking about Bjorn's work. We want a test that is a good proxy for user experience, because we're in the situation now where Jim Geddes identified buffer bloat. We had a bunch of work done on FQCODL and Pi and L4S, and we have the tools. But then I put myself in the shoes of an engineer working at Broadcom, making Wi-Fi chips or making any kind of network device. And they read about L4S, they read about buffer bloat, they say, this is important, I'm convinced we should do better. And then they change that code. How do they know if they've done better without a test? And that was sort of the light bulb moment for me a couple of years ago, which is that without a benchmark we all agree on, it's very hard to make progress. And that's why we haven't made progress in 10 years since, well, let me say that differently. For a long time, we didn't make any progress after Jim Geddes identified the problem with buffer bloat. Thanks to Cable Labs and Comcast and others, we actually are this year making progress, but it's taken a long time, and we're not making as much progress as we would like with the Wi-Fi community. So there's still a lot of work to be done. And what I realized is when an engineer makes a change, if we convince the Wi-Fi engineers and the Wi-Fi companies, you could do better at delay management, and let's say they're all on board with that and they do their best, how do they know they've done a good job? And right now, you do a Zoom call and you stare at it and you go, does this feel better? I don't know, maybe it's better. So having a repeatable, reliable benchmark is absolutely crucial to help engineers know when they've done a good job and to inform customers about which product they should buy. Because right now it's really clear. If one ISP is offering you 10 megabits and the other ISP is offering you a gigabit for the same price, and you can measure with speedtest.net to verify they're telling the truth, you're probably going to go with the gigabit because it's more. And that will correlate with downloading apps is faster and starting up a 4K stream is faster. So having a tool that is a good proxy for user experience is absolutely crucial, because this is my opinion. If the tool is not a proxy for user experience, what's the point of it? It's just measuring an arbitrary random number. Who cares? So that's my number one requirement. And I'd love to hear the feedback. I hope the answer is people agree. But my number one is it has to be relevant. It has to correlate to user experience. Number two requirement is it has to be repeatable. If there's a lot of random noise, if you run the test 3 times in a row and you get 3 different answers, well, you don't know whether the change is due to your code being good or your algorithm being better, or whether it's just a random noise in the test. So consistent, repeatable results, I think, is a close second in terms of importance. A third goal we have is it's really nice if you can run this test and get an answer in 10 seconds. We might not be able to have all 3. We might have to pick 2 out of 3. And if we do, my vote is for relevance and repeatability. But again, I'm putting this out for discussion because I want to find out if people agree. There are some other observations in the overview section which are less important, so I'll go through them quickly. One is when you're measuring bandwidth, you're measuring the throughput of the slowest link. And as long as your client and your server can go faster than that, they're not limiting the bandwidth. So bandwidth is sort of a min function. You take the bandwidth of all the hops and you report the minimum one. Delay is additive. You're adding up the delay at every step. So any delay caused by the test server or the test client are included in those numbers. So hopefully this is sort of so obvious it barely needs to be mentioned, but I did want to write it down. Having high quality test servers and test clients is essential to minimize the amount of noise that they're adding to the data. And any research scientist knows this, that your measuring instruments can contribute noise themselves, and you want good instruments to minimize that. So hopefully that's a fairly self-evident thing, but I wanted to write these things down because if they're not written down in the draft, we don't actually know if the working group agrees on these things. I also elaborated that the purpose of the tool is to measure network performance. And the reason I mention this is because there's a secondary use of the tool. You can tell if your web server has poor real-time behavior. And that's a useful test. But the document had kind of got a bit mixed about what its goals were. So I'm going to assert that the primary purpose of this test is to test the network. Having done a good job at that, you can now point this tool at your web server, and if you get a lousy score, that might motivate you to go and look at the buffer tuning on that web server. But that's a secondary benefit, and our primary thing is to measure the network. We have a question?
Yes. Very.
Mike is dying.
Mike is
Maybe the battery's low. It's cutting in and out.
oh, you,
They managed to have a loose wire on a wireless microphone.
They're internal wires.
Okay. Or we
But
can
for
come
the
up here
remote
and-
people,
Yeah.
just come up.
Come up
just
and
come
take
up.
the question here.
Use this so the remote people.
So that is very interesting point there. Whether this metric allows separation of their network measurement and application measurement, because my understanding that actually that metric combines propagation, queuing, and host processing. Whereas when we do network measurement, we try to separate the host processing from propagation and queuing, and even further, for example, when we collect metrics using some other methods, we try to separate propagation from queuing. Because, for example, we have resonance time measurement, or we have transit delay metric collected using in situ OEM. So that's what's not clear to me, how this metric separates, because, for example, if we take active measurement methods, so we use timestamps that are collected on transit and receive by the session reflector, for example, and then session reflector records its transmission timestamp, and their session sender, receiver of reflected packet, takes it of reception timestamp. So that's way we exclude the host processing. We're looking only on what's on the wire. That, of course, combines the propagation delay and the queuing delay of all transit nodes. But that further can be separated using other tools. So that was not clear, but it's very interesting to me.
Thank you. Yeah, the point you make is correct. This test, and this comes back to point one, the relevance, we wanted to measure the things that affect behavior of applications. And that typically means HTTP GET. I'll come on to that actually on the next one. And yes, that includes software overhead on the servers. And I make no apology for that. That's just the direction we chose to go with this, because we want to avoid this thing that happens sometimes where we measure something about the network and say, in fact, somebody was commenting yesterday that my wife says the network sucks, but I ping the gateway and it's really good, so I tell her the network's fine. That's not helpful. If the network sucks, it actually sucks, and you want a test that reflects reality, not a reflect that says, hey, not my fault, ask somebody else. So for that reason, we did go with something that includes all the end-to-end delays, which is why I highlight that if we're going to do that, we have a responsibility that we tune those endpoints so that that software overhead is minimized. It's still there, but we want it to be small relative to the other things that we're measuring. And one of the unexpected side effects of this, I mention this because it seems like maybe a side issue, but it was actually incredibly valuable. When we were doing testing at Apple, we did some work on our test network and we configured it so we eliminated buffer bloat and we got a really good round trip delay. And then we said, well, that's nice, but how does this relate to real user experience? And one of the things we expected to be really good was random access in videos ought to be super snappy when you don't have 2 seconds of stale packet sitting in the network. And it should be faster than skipping chapters on a DVD, because on a DVD player, that little laser's got to physically move, and that takes a quarter second. So you ought to be able to do random access in network video faster than you ever did with a DVD player or a Blu-ray player, and of course, much faster than VHS. But accessing network resources should feel faster than accessing a local spinning optical disc. And we tried it, and it sucked. And we were very disappointed. And we said, what have we done wrong? and it turns out we had a couple of seconds of buffer bloat inside the sending servers, just because the way the HTTP servers have been configured, they said, hey, RAM is cheap. If buffering is good, more buffering is better. So they put in these huge buffers. So when you're playing video and you suddenly want to skip ahead to a different chapter, there's a new HTTP GET for the new data you want, and it is stuck at the back of this queue of data that's already been given. The HTTP server had a buffer, the TLS layer had a buffer, the socket send buffer in the kernel had a buffer. There was something like 4 megabytes of stale data sitting there that was already committed to this pipeline, and you had to wait for that slowly to trickle out, even though you didn't want it anymore. So an unexpected side effect of running this test was we figured out that our servers were just badly configured. We tuned that 4 megabytes of buffering down to like 128K, and we expected to see degradation in other metrics, and we didn't. All we saw is we were using a lot less RAM, and everything was faster. Random access in video was faster. Scrolling in maps and fetching new tiles was faster. Anytime you're waiting for data from the network, it got faster, and we used less RAM. So that was sort of an unexpected benefit of this. I don't want to run out of time, so I'll move on. I include a section on why we use HTTP. And again, this is there because I want to get feedback. I'll express my opinion, which is I am not terribly convinced that every application is a unique snowflake with its own requirements. I think all applications want the same thing. They want high throughput, low delay, low loss. You're not special. You want the same thing as everybody else. And we use HTTP not because that's what people use for web browsing. I believe it is a good representative test because it supports, it describes it in the document. It supports multiple concurrent operations. It supports interleaving. It supports cancellation of things that you don't want anymore so that you can request something new. And I think that covers a broad spectrum of what most protocols use. And at the IP layer, packets are just packets. They could be video conferencing packets. They could be TCP segments containing TLS, containing HTTP2, containing cat pictures. They're just IP packets. And you either deliver them quickly, or you delay them in buffers, or you lose them. So I make this assertion that HTTP is actually a good proxy for a broad range of applications, including video conferencing. And then the final point is we believe that this test, if we're successful, and this applies to many of the work, much of the work done in IPPM, if a benchmark is widely accepted, then companies and engineers will start optimizing to score well on that benchmark. And sometimes they can optimize in cheating ways. To famously, people used to complain that ISPs would special case speed test, so you'd get really high throughput, but only when you connect to speedtest.net. We want to design this test so that anything you can think of to cheat actually lowers the real latency for user traffic. And that's the kind of cheating that we fully encourage. So having it, and that's another reason that if we use HTTP GET instead of ICMP echo or something else, we're measuring the same thing applications care about. So it becomes much harder to accidentally do something that helps the test without being useful. All right, let's move on. So here is a specific call for input, and I've sent out email on the IETF list, and I've reached out to the best of my ability to individual teams, and I'd love it if other people would help. Right now, as the result of how the documents evolved, we've landed at a stage where draft 4 and 5 say you gather some round trip measurements, you throw away the worst 5%, and you take the arithmetic mean of what's left. Now, I don't work on video conferencing software. I'll tell you how I think it works. You have a stream of UDP packets. Some may be delayed, some may be lost. On the receiving end, because this is not TCP or QUIC, it's not putting the data into order for you, the client gets the UDP packets. They arrive when they arrive, and the client gathers them in a buffer. And at some point, it's got to decide, now I'm going to play the frame. Well, if it's missing half the packets, it's not going to be able to decode a heavily compressed H.265 frame very well, so you're not going to get a picture. If it waits long enough, it'll have most of the packets or all of them, but that could add a 2-second lag, which makes conversation really hard and you keep interrupting each other. So I imagine the engineers who work on WebEx, Zoom, GoToMeeting, FaceTime, WebRTC, others, I apologize for forgetting any, they all must have an algorithm that works out the size of the playback buffer and works out how long to wait before playing the frame in order to make sure that they have got, because if they pick the median, if they pick the median time as their playback time, that is the same as saying you're having self-inflicted 50% packet loss because you're playing the frame when you only have half the packets, and that's probably not going to work. So are these buffers tuned for 95% of the packets have arrived, 98, 99, more than that? I would love to hear directly from the engineers who do that work what they actually do instead of us. We have smart people in this room, but we're kind of guessing what we think they do. And let's move on to the next slide. Those engineers might think that their playback algorithm is their secret sauce and it's their competitive advantage. I would like us all to encourage them to look at another aspect of this, which is if we can make this test be a good proxy for video conferencing experience, and if this test is widely accepted so that operators and vendors tune their products to do better on this test, then that will make the internet work better for video conferencing. You don't have to ship a video conferencing app like WebRTC and just make do with the internet how it is. This test actually offers the opportunity to change how the internet works to make your application work better. And it will only make your application work better if this test is a good proxy for how your application works. So there is an opportunity here before this is published as an RFC to actually get the to make sure whether you work for Zoom or Cisco WebEx or wherever you work, if you get your input into this test, your end result is that the internet will evolve and your application will work better. So I see this as a great opportunity if they're willing to give their feedback on that.
So Abhishek, please come up here.
Thanks, Stuart. I have Abhishek from Meta. I have a couple of points. So one on your repeatability requirement. So the way it's written right now, if everything has to be extremely repeatable, let's take the extreme case, that means the variance has to be 0. Even that an engineer would not trust. So there is more detail to it. I mean, there has to be a balance because if you're measuring something over the internet, some amount of variance is expected because the conditions would not be. So that's one comment.
Yeah, so I agree. I think variance 0 is not realistic. When you buy groceries in the supermarket and they put them on the scale, right? We know those are not scientist grade scale milligram scales, but you expect it to show about the same result, plus or minus a couple of grams each time. So that's what I'm talking about here is, maybe a 1% variation in the score is tolerable, but if it shows 50 one day and 80 the next day and then 60 in the same conditions, now you don't trust the test. So that's the question is like, we need, so repeatability doesn't mean 0 variance, but it means low enough that you trust the results you're getting.
Yeah, so just the point was just to, maybe it needs to be worded correctly. Okay. The second point I had was in your RPM measurements, I was surprised to see that you're saying throw away the 5% of the worst measurements. I mean, just in the previous talk, we discussed that the outliers are very important. It's the worst case performance that a lot of times so there's a disconnect between these.
Thank you for saying that. That's exactly why I came here, because my personal view, speaking as an individual now, not one of the co-authors, is I think the ship has gone off course. My personal view is throwing away the worst 5% is not the right thing to do. it does have this side effect that it makes the results much more repeatable when you throw the outliers away. So this is the tension between repeatability and relevance. And I personally have concerns, which is why I'm raising this issue in front of this audience. And I'm glad to hear that you agree with me. Um, uh, but this is a work group consensus document. The fact that I have concerns with it is like I get one voice in this process, but everybody else's voice is important too.
So Warren Kamari without any hats. I think I just kind of got triggered on the relevance bit because I think that that will change noticeably sometimes between, you know, it's 95% good and it's 2% good, depending if there are other people in the house using the network. You know, if my cousin, auntie, whoever is also in the house and she's downloading monster huge torrents and stuff, the network performance is different. And so I would expect the output of the test to be different in some ways.
So our
over
belief
Okay.
is that you are wrong about that. And
Okay.
our belief is that it is a very widely held view that the performance of your Zoom call is naturally going to degrade when the network's busy. And I say, I don't buy that. The fact that they do today doesn't make it a necessary outcome. And I think part of the thinking is we apply human experience to how we think networks work. So we think about thank the airport at Thanksgiving or mailing a package the day before Christmas at the post office. When things are busy, life sucks and you have to wait a long time. But here's the thing. If I've got, forget gigabit, I've got 100 megabit internet service to my house. 1 megabit is enough for a pretty high quality video conference. So somebody downloading as many torrents as they want and downloading apps and iOS updates and streaming 4K video all at the same time should make literally no difference to my video conference. And that's not true today. But by keeping queues short, with or without flow queuing, we can make it so that no matter what people are doing on the network, you never notice the difference. And that's the goal of this work, is to move the whole industry in that direction.
Okay. I mean, I can happily tell you when my wife turns on the microwave, my internet stops in part of my house.
We need
and
we need better firmware on your equipment. So we should chat about this, because you're touching on one of the really key points. Is the thing you just said, when other people in the house are using the network, it sucks. This was a meme joke during the COVID pandemic. Is like, kids, get off Netflix, mummy's got a work meeting. And people just chuckled and laughed about that, like that was just the natural state of the world. And that really annoyed me, because that should not be the state of the world. The whole point of the internet, as in contrast to circuit switching and ISDN and all the things that were debated between the bellheads and the netheads in the 80s, the point of the internet is it is a shared network. And the truth is, we haven't learned how to share it very well. I can tell. Tommy is telling me to stop talking.
I just want to point out that I've cut the queue.
Yes.
And no, it's fine. We can finish this up quickly.
I mean, I agree that that shouldn't be how the network is now. I mean, it shouldn't be how the network is. But I think at the moment, we have clear evidence that when people are doing stuff, things get worse. So if you
and I should sit down with a coffee or a beer or something, and I will try to convince you that it doesn't need to be that way. We know how to not make it that way. And the point of this test is to whack people on the head and say, hey, deploy the new software that works better.
One thing to clarify, like, Warren, have you read and followed this? Okay, so because like this is the metric is loading the network, like it is intentionally measuring it when it is causing it to be like when your other person is doing the torrent. Okay, just want to clarify.
If the metric didn't change now, I run the test now and the metrics didn't change, I would not trust the metrics, because clearly. Anyway.
Well, this metric should show that on your network you have a bad time. Yes, it should show that you have a bad problem. Yes.
Yes.
And it should be consistent in showing that until you fix your network. Great. Okay. Timothy.
Yeah, Tim Panton, Pipe. So this slide, I think I can maybe help you a little bit on how video conferences think. And this slide is kind of wrong in that you don't render a frame until you've got everything. And there are two basic algorithms for making sure that you get everything. One of which is to you back off. So if you look at the bit rate you can get through, you try and estimate that, and you push down until you're within the envelope of what the end to end you can achieve. And the other thing is you ask for retries to get your full packet. Jonathan can tell you a ton more about it, but essentially this slide is kind of semi wrong in that there is no percentile. You either get all of it or you don't render the whole frame and the next frame until you get a full frame. So there's like a big penalty to losing a single packet.
So I will tell you that I personally agree with you. However, I have heard the opposite from many people who work on video conferencing systems who say I am completely wrong, and they love what they call loss tolerant codecs, where they can play a frame when they don't have all the packets. Now, this has changed in the days. I remember the Cambridge Ring where we did video and it was uncompressed images. When I say uncompressed, I mean not even JPEG, not even still compression, because JPEG didn't exist. When you have uncompressed images, playing it when you're missing a packet is no big deal. When you have highly compressed images like H.265 and more, then yes, losing one packet makes it extremely hard to recover. So I personally agree with your comment. However, this slide is reflecting what I've heard from other people, and they refute that.
Right.
So let's see
I
where
think
Jonathan lands
so
up on that, because
Timothy,
he's got an opinion as well.
yeah, we're just going to get through the queue. I think this is all good to take to list as well. So very quick.
So I'll be very quick. What the discussion here reminds me of past things as well. I think there's also the notion of network dimensioning. As you're saying, you could have 100 meg at home. We're seeing in the broadband today where we're going 100 meg, 1 gig, 10 gigs to the home and so on. But, honestly, I could be a heavy user. I never use 10 gigs. So the network operators have always be used to throwing more bandwidth to fix quality of experience or quality of outcomes and so on. But at some point, we were also talking since 1995. I was already at some events, quality of service, queuing, all of these things, prioritization of applications based on what they're supposed to be delivering. And we're still not really doing it in the core of the internet for the user experience because people continue to throw bandwidth. So, and you can throw 10 gigs into a residential home, it's not going to fix the problem of what's happening in the core of the network, which are the weakest links, because even if you have 10 gig at your home, the network operator is not provisioning 10 gig in the core network for you.
I'll very quickly agree with you. For 20 years, we've been throwing bandwidth at the problem and we haven't solved the problem. And it may be time to realize that throwing bandwidth has not been the right answer.
Great. Bjorn.
Yeah, Bjorn Domus. Yeah, I just want to show support for not throwing away the 5% worst samples. I think those are very important. And a lot of the time, that's where the signal really is for this stuff.
Great. Jonathan, last word.
Yeah, Jonathan X. So I think for what we're talking about here in terms of user experience, video is complicated and actually fairly loss tolerant, which is to say we do retransmissions. If you're a little late, it doesn't matter that much. Audio is actually much more sensitive. And I think thinking about this in terms of what audio is doing rather than what video is doing is probably clearer for talking about this. The other thing I wanted to say, I mentioned this to Stuart privately yesterday, is that in my experience, a lot of the bad experience, so insofar as the network is being roughly a steady state, video conferencing systems usually adapt fairly well. It's the sudden, glitches, something strange just happened that it gives a really terrible experience. I gave the example of, like I've had systems where, once a minute, the Wi-Fi decides to channel scan and shut itself off for 500 milliseconds. And that's terrible in a video conference. So I'd like to be able to see that happening, which might mean a longer test and certainly looking for low percentile things.
Yep, thanks for that feedback. I will update the document. In retrospect, talking about video frames was probably not the best example to use to make the point. I think audio chunks is a better example. Thank you.
All right, thank you. And process-wise, I think we're going to need, another last call and all stuff on this since we have such changes. Just making sure that's clear. Okay, Giuseppe. Yes. So we're not going to get to our lightning talks today. So we're just going to get through this, and you've a couple things, so we'll condense a little bit.
Yeah, I will try.
Yeah.
I don't have so many
Yeah.
slides, so yeah, this is an update about the alternate marking deployment framework draft. I'm presenting on behalf of the co-authors. Yeah, this is a summary slide. So just to say that the scope of the draft is to provide guidance for the deployment of the alternate marking method. You see the relevant RFCs. The aspects that we aim to clarify are the deployment domain, that is the limited controller domain, the measurement nodes, so specify the marking, unmarking transit nodes, the type of measurements based on the available flags, and in particular the configuration aspect, so Young model, PSAP or BGP for the configuration and data export, IPFix or Young notification, Young push, and the different available encapsulation, mainly IPFix, SRv6, and PLS. Next. So quickly, regarding the change from the 0.1 to 0.2 version, some comments were received during the last IETF and have been addressed in the new revision, but in particular the additional alternatives for the application of the altermark method to IPv6 and to MPLS, and other minor changes and references updated. Next. Yeah, this draft looked quite stable. I don't want to ask for working group plus core. I'm joking. Yeah, we can consider it for working group plus call if there is anything else to clarify. But I see that there is a long queue, so we can discuss.
I think I noticed though, amongst all the authors asking for working group last call, we have a good enough set that as long as they all review each other's documents, and we don't let them progress until they review each other's documents, we'll be good.
Yeah, mutual responsibility and cross-pollination. Greg Mirsky Erickson. Actually, what I would propose to look at, one of the mechanisms for collecting their information is a hybrid two-step.
Yeah.
Because and I would like to work with you guys on thinking about it, because one of the advantages that we can have is the simplified correlation of data, because data will be collected for the same trigger, so their collector entity will have an easier time to correlate them.
Yeah, indeed. During your presentation, I was thinking to add the reference to your document.
Yeah, let's discuss it offline, and then we can move something in the text. Thank you.
Okay, thank you. Next.
Yeah, so you want to go to the next?
Yeah.
So now we're moving on to non-adopted documents that we have had discussion on.
Yeah, this draft is related to the previous one because it's one of the mechanisms for the configuration. So it specified the Young data model for the alternate marking method. Next slide. Yeah, basically this is the Young data model. It's very simple. This draft is from the result of two previous drafts about the Young data model. Now we only have one Young data model. We agree on the structure, and it's important to highlight that we follow the same structure of the RFC 9617 about the OIM Young data model. Next slide. Yeah, the information are profile name, filter to identify the flow, method type. So according to indicate the type of the alternate marking method, the type of protocol, the node action, so mark, read, or unmark, the period, the monitor identification, the measurement mode. So in few words, all the parameters that are needed to configure the alternate marking method. Next. Yeah, this draft is stable. The only change was to reduce the number of authors to 5.
Thank you.
And yeah, we asked the working group to consider the working group adoption for this.
Greg Mirsky Erickson. Yeah, I think it's very appropriate to work on this, and thank you for taking this work on. What I would like you to think about, and we can discuss it later, is that their mark packet that enables the to mark. It can it be used not only to do accurate measurement of delay, but also to generate operational information analogous to what's being done with the in situ OEM. Because effectively, you have a trigger packet. So you can configure any information to being generated on a node when it receives this packet. Okay, so that can be not only loss and delay measurement, it can be generating queue depth and everything else. So think about it in this direction, and we can discuss it on a list.
Yeah, we can see if we can incorporate an additional parameter or just integrate in the existing one. Okay, thank you. Okay, so
the next one.
Yeah, this is the document about that I mentioned before for Rakesh regarding the comment for Rakesh draft. Is about the on-path telemetry for active performance measurement. So next slide. Yeah, in several scenarios, it may be beneficial to perform hop by hop together with end-to-end active measurement. So basically, if we have active test packets that can be used in combination with hybrid methods to perform on-path active measurements. So we have some example for ICMP, ICMP v6, and OWAMP, TWAMP, and STAMP, where we can couple the ECMP v6 packet with the IPv6 of hop-by-hop option, or the STAMP or OWAMP, TWAMP packet with the IPv6 hop-by-hop option. The same supply for the MPLS data plane. Next. Yeah, in particular for IPv6, we already published the altmark IPv6 hop-by-hop option, that is the RFC 9343, and the IOM IPv6 hop-by-hop option, that is the RFC 9486. So it would be quite easy to couple this hop-by-hop option with an active tools that can be an SCMP v6 packet or a STAMP session or OWAMP, TWAMP, and so on. And it's important that this draft is just informative, informational, because this approach is not adding any new functionalities to existing protocols. So it's just leveraging existing mechanisms, because you can use the Young model that I presented before to configure the hybrid tools. And because we already have Young model also for IOM, together with alternate marking, and you can use IPFix or Young notification on hybrid two-step and so on to report telemetry information. Also, STAMP TLV has also been proposed and can be used for this reporting purpose. Next. So some comment have been received from Xiaomin, and is also would like to join this draft, and probably I will add as co-author in next version. So basically, we added the case of MPLS echo request reply. We included the case of MPLS LSP ping and other minor changes. Next. Yeah. Again, let's evaluate the adoption of this draft, since also there is some interest on this and on this idea, and the idea of coupling hybrid methods with active tools can be good to be referenced in some way.
Xiaomi ZT. Quick comment. I see you have a reference to the 6-man draft that ICMPv6 rollback. And now we have a new merged draft that replaced that one.
Okay.
So it's ICMP reflection. Yeah.
It needs to be updated, right?
Yeah.
Okay.
You need to update that reference. Thank you.
Thank you.
Cool. That sounds good. Yeah. I think we're gonna. It sounds like we have a lot of other calls.
A lot of calls to make.
So we're probably trying to process some of the queue before we get to this, but
Yeah.
this is good. And any comments or feedback we see on list is always helpful. Please review and comment. Um, also, yeah, I mean, if this is appropriate to reference from our other documents, then that kind of helps. Okay. Thank you, Giuseppe.
Okay. So we have Zhang for stamp MP.
Good afternoon, everyone. This is Li Zhang from Huawei. I will introduce a stamp intention for multipass and on behalf of my colleagues. Next page. And so what's new in this version? We extend the stamp inside of LM to avoid the inclusion problems, and we provide more detailed descriptions on the procedures, and we also split the new draft to address the round-trip co-path measurement. And next page. So why we propose this work, this is because the stamp are typically for space paths. It can't collect all the passes on the same time when there are multiple paths. Also, we can achieve by constructing different IPv6 flow labels and MPR's entropy labels, but it's very hard to know whether all the available paths has been measured, and also it can only realize the Huawei performance measurement. Next. And so we extend the sum with a multipath TLV. We define a M bit in this TLV to indicate a multipath measurement. When a translator receives this packet, it will duplicate this packet to all the interface which can reach to the destination. Okay, next. So here is the detail about the procedures for the session sender. It need to incorporate some fields to the test packet. The first one is a multipath TLV is defined in this document, and the second one is to incorporate a correlated bidirectional path flag of return path control code sub TLV. It's defined in another document. Is used to indicate the reflected packet should be forwarded on the same path as the corresponding test packet. And also LM hop by hop options. It is used to distinguish different paths by collecting the hop by hop information. And also reflected IPv6 intention header data TLV to indicate the session sender to session reflector to reflect the LM fields. And next page, please. Okay, and for the transit node, it just needed to add its own node ID interface ID to the LM trace option, and then duplicate the packet to each egress, which can reach to the destination. And for the session reflector, when it receives a packet with multipath, it should copy the IPv6 options to the reflected packet and reset the F bit of the reflected packet to prevent the replication in the backward path. And also need to encapsulate the set list to the reflected test packet to make sure it is forwarded along the path which the test packet is forwarded. And also you need to maintain a counter for each path. But this is only required when using the stateful mode. Next page. And okay, for the analysis node, it need to determine which test packet the reflected packet corresponding to based on the session sender circle number, and distinguish different paths based on the reflected IPv6 extension header TLV, and generate a table for all the paths and record the sequence number for each path. And it can get the round trip packet loss for each path in the stateless mode. And in the stateful mode, it can get the forward and backward packet loss. And finally, it can get the forward and backward transit delay of each path by comparing the time steps of the reflected packet. And the next page. And we provide a simple example about the multipath measurement using stateful mode. The first figure shows the transmission of two test packets. The node 1 generates two test packets, and they are when this packet arrived to node 2, and the node 2 duplicates these two packets to each egress, and the node 2, node 3, node 4, node 5, just it is all information to the environment trace option, and all these packets are arrived and reflected at node 6. And the second figure shows the transmission of reflected packet. In the transmission of reflected packet, the packet 1.1 is lost, and finally the node 1 just receives 3 packets, and it will find there are 2 paths which can reach to node 6, but one path is 0% loss and another is 50% packet loss. Okay, next page. This is a response to the question that this document is a little similar with the IPPM asymmetric packets. I can type this to the mailing list. Next page. Okay, and for the next step, I would like to add MPR's data plane solutions to this draft and continue to improve the quality of this draft. And as usual, we welcome for any comments and opinions. Thank you.
Yes. Hi, Greg Mirsky Erickson. So I think that it is, well, the measurements are useful, but I see that it's already can be realized because, for example, if you have downstream multipath, so that is a data plane encapsulation. You run separate test sessions for each of the available paths by using segment source routing, if you use a strict source routing, or using the same entropy value for the flow ID for their hashing. So basically then have a separate downstream. For the return path, you can use existing return path TOV that commands how packet is reflected. So that would give you a very deterministic way of associating downstream and reverse directions, so downstream and upstream directions. So, but yeah, again, it requires some work in the data plane, and but I think that as far as stamp extensions, they already exist.
As I have mentioned in the slides, I think constructing different IPv6 flat labels and MPR's entropy labels, it has some shortcomings because of the hashing algorithm. It is hard to make sure all the paths has been measured. So,
well, again, yes, if we talk about that systems that use label stack or IP header information to generate entropy, that's a black magic. And I don't think that stamp extensions will help you any. So it's probably we can get a deterministic identification of the path traversed only if it uses dedicated entropy values. So if it's a black magic, it's black magic.
Okay, let's discuss offline. Thank you.
Rakesh?
Rakesh Gandhi from Cisco Systems. You don't have slide numbers, but there is a slide for stamp TLV.
Yes.
If you could,
Maybe pages.
yeah,
Yes.
yeah, it says that when transit node receives a stamp packet with this flag set, it should duplicate this packet to all interfaces. Is that the intention, or is it? Did I understand it right?
Yeah, yes, maybe some information is here. It means when the node enables some like ECMP and UCMP, it has multi-paths can reach to the destination node, then it should duplicate the packet.
Because this means the transit node. So today, just let's say if it's doing IP forwarding, it has to
Yeah.
know the next header is UDP. Then it has to find out that UDP header is for stamp. Then it has to go and start parsing the stamp packet. Then it says, oh, there is a TLV for stamp all the way at the bottom, and say, oh, there is a M flag set. And oh, after doing all of that, now it's I need to copy this packet everywhere. That's what you're asking a transit node to do.
Good question. I need to consider this question. Thank you.
Thank you.
Xiaomi ZTE. I agree with what Rakesh said, because currently the transition node cannot do that check for the stamp TLV. They have no such capabilities now. So, they just forward the packet on header.
Okay.
Thank you.
Okay, thank you.
Okay, thank you very much. So we have 4 minutes left. So there probably is not enough time to go through our lightning talks, unfortunately. So
yeah, I mean, I would encourage people, you can look at the slides that have been uploaded. They're one-sliders. They should all be things that people attend to the list that didn't receive discussion yet. Go look at them, see if they're interesting. If you think they're interesting, comment on the list. Help engage with the folks who did that. And thank you to the people who presented and engaged here. Thank you to the people who made slides who couldn't present for those lightning talks. We still appreciate that contribution. And yeah, good, robust discussion. Probably a record number of things asking for working group last call. We will have to make decisions about that. But thank you all. We'll see you next time and on the list. Also, Warren had sent out a thing a couple of weeks ago asking for people, if you want to get involved in leadership within the area, fill out a form, and that'd be good. I've been chairing this for a while. I'd like to step down sometime soonish, get some new folks in here, maybe people who are more from ops area. So if you're interested, please fill that out.
You're doing okay?
Yeah, just because it's such a big, it's not a big storm change.